Hi everyone, in this tutorial we are going to talk about the Cahn-Ingold-Prelog rules, also known as the CIP rules. You've heard me so far kind of dance around this idea of classifying asymmetric centers as R and S, and also classifying alkenes, carbon-carbon double bonds, as E or Z. Now, it's important before we even talk about how to classify them, the process by which we do that. Before we do that, we have to talk about these Cahn-Ingold-Prelog rules, because we have to be able to assign relative priority to different atoms and or groups, and that is done by using the Cahn-Ingold-Prelog rules. Okay, so again, these will apply to determining R and S and to determining E versus Z alkenes. We're going to go through some examples here just to show you how to rank groups, but the ranking system here, I want you to think first and foremost, this is important, it's about atomic number. Higher atomic number atoms get priority over smaller atomic number atoms. Okay, so for instance, if this is the asymmetric center, this little squiggly line here, that's kind of the assumption. If you're ranking these in relative priority, it's first and foremost about atomic number. We have carbon, oxygen, fluorine, and oxygen being the direct attachment points. Carbon is the lowest priority because it has the lowest atomic number, hence why we give it, say, priority 4 if we have 4 to rank. Then we would say fluorine has the highest atomic number, it beats the oxygens. And then now that you have oxygens, right, the oxygens are tying in that direct atom that we're considering, okay? So now we need to progress to rule 2 of the Cahn-Ingold-Prelog rules to distinguish their relative priority. And the second rule is if the atoms directly attached to the carbon, to the chiral carbon or EZ double bond carbons, tie in atomic number, then those carbon atoms, or in this case oxygen atoms, now become our reference point, and we consider the atomic number of the atoms that are directly attached to those new reference points, whether they're carbon or another atom. So because the initial atoms, oxygen, tied in atomic number, they become the reference point, and we say what atoms are bonded to them. Oxygen here is bonded to carbon. On the far right, the oxygen is bonded to hydrogen, and it's still based upon atomic number. So carbon beats hydrogen. Therefore, we have priority 2 and priority 3. So I'm going to repeat that. If there's an initial tie, okay, in the direct atom attachment in terms of atomic number, then we consider those atoms as being the new reference point visually. And then we consider their direct attachment points just within one bond, very important to do one bond at a time, and say what are those atoms' atomic numbers. Okay, always by atomic numbers. Okay. Now, the next rule of the Cahn-Ingold-Prelog rules is that we will give doubly bonded atoms single bond equivalences, and we will similarly give triply bonded atoms single bond equivalences. What that means is if you had a C double bond O, we would classify that technically as a carbon making two, quote unquote, two oxygen connection points. If you had a carbon triply bonded to a nitrogen, we say that carbon is bonded to 3 nitrogen atoms, okay, according to the Cahn-Ingold-Prelog rules. The last rule is number 4, and the rule states that larger isotopes with more neutrons get priority over smaller, less heavy isotopes. The best example of this is deuterium versus hydrogen. Hydrogen has an atomic number of 1. There is 1 proton, 1 neutron, 1 electron to the atom hydrogen. Deuterium is a heavier isotope with 2 neutrons, and deuterium is represented as D, and deuterium is higher priority than hydrogen, but deuterium would lose to carbon because carbon's atomic number is higher. Okay, so heavier isotopes like deuterium would get preference and priority over their less heavy isotope, hydrogen. All right, we're going to go through a couple more examples. So remember, we're considering that this squiggly line is the attachment point to the chiral carbon. So first and foremost, we're looking at the atom directly attached. Okay, and here bromine is the highest atomic number. Therefore, it is priority 1. Hydrogen is the lowest atomic number atom, so therefore it is the lowest priority, priority 4. Then between nitrogen and sulfur, sulfur is a higher atomic number atom. It's 1 periodic row below nitrogen. It will be priority 2, and the third priority is our nitrogen atom. we're going to do number 3 together now. Again, chiral carbon is here, right? And our direct atomic connections are carbon, 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 and carbon. And we're like, dang, we're tying an atomic number. So now those carbons become the reference point, and we say, what are they bonded to? So this first one on the far left is bonded to 1, 2, 3 carbons, right? The next one is bonded to 1 additional carbon and 2 hydrogens. So we're going to say carbon and 2 hydrogens, which is already going to lose to the first one because carbons beat hydrogens. And notice that if the atomic number ties, then the number of those atoms becomes consequential, and 3 carbons beats 1 carbon. Okay. Progressing now, we have a carbon here that is bonded to hydrogen, hydrogen, and hydrogen. This would lose to the carbon, hydrogen, hydrogen, because carbon is higher atomic number than hydrogen, hence why this is the lowest priority of 4. Then in the last example, we have our carbon, and it is bonded to carbon, carbon, and hydrogen, and its priority 2, beating this situation where you have carbon, hydrogen, hydrogen, 2 carbons beats 1 carbon, but 2 carbons loses to 3 carbons. So again, here if the atomic number is tying, right, then it's the number of those atoms that can become consequential, and the more of those numbers of atoms that wins, okay? But if that initial atom, like we did at first, carbon, 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 is tying, then it's a matter of what are they attached to and what are their relative atomic numbers. We'll do one more example together. Okay, so the direct atomic connection is carbon, chlorine, oxygen, and carbon. Let's write that down. So direct attachment point is carbon, chlorine, oxygen, and carbon. Chlorine is the highest atomic number, therefore it is the highest priority, priority 1. Then we have oxygen beating the carbons, okay, hence why we have priority 2. And then because the carbons tie an atomic number, we say, what are those carbons bonded to within one bond? On the far left, that carbon is bonded to 1 oxygen, another oxygen, and another oxygen, right? We give the double bond, single bond equivalences, saying there is 1, 2 oxygens, and a third oxygen. The one on the far right here has a connection point to a carbon, an oxygen, and an oxygen. We give the double bond, single bond equivalences. And 3 oxygens beats 2 oxygens. Okay, remember, tie an atomic number technically, but the number of those atoms is now consequential, and we give this one on the far left a higher priority than this group. Okay, I cannot stress how important it is to know these Cahn-Ingold-Prelog rules, and always consider it is based upon atomic number, and if the atomic number is tying, we have to go one position further and look at the atomic numbers of those connection points within one bond at a time. You have to be very meticulous. Give double bond and single bonds, double bonds and triple bonds, single bond equivalences, and heavier isotopes get higher priority.